I need to close that bracket. Close that down there. Goodness. And we're going to put the du over dx out here. Now to get du over dx, we're going to take the derivative. So we have du over dx is equal to I think my eyes are going bad. That's supposed to be a 3 there, but hold on just a sec. Thought I wrote a 3 in the problem, but that's just a 2 there. Okay. Doesn't matter. This would be 2x. There we go. Okay, so by the second fundamental theorem of calculus, this piece right here is going to end up becoming just cosine of u times, and then we have the du over dx, which is 2x. And guess what? This is equal to, we're just carrying this down, f prime of x. But don't leave a u here. We need to go back and substitute back in, so this becomes cosine of x squared. And I guess it'd be appropriate to bring that 2 over there, I suppose. Now what you could do, instead of going this route, you could go ahead and take the integral of this, and once you take the integral of it, then take the derivative, and you should end up with this exact same piece here. In fact, let's just do that. Let's take the integral of this, and I guess we'll just go on down and rewrite this. The integral from pi halves to x squared of cosine t dt. So remember what the integral of cosine t is. It is sine t, and we're going from pi halves to x squared. So now what we're going to want to do is go ahead and plug our upper and lower bounds, our upper bound and lower bound in sine x squared minus sine pi halves, and remember this is all equal to our f of x. Now what is it that we were wanting to do earlier? We were wanting to take the derivative of this, right? So f prime of x is equal to, now the derivative of sine is going to be cosine of x squared, and then of course we have to do the chain rule, take the derivative of this and chain it outside, which is 2x. But what is sine of pi halves? Well, remember sine is the y coordinate, and pi halves is up here. Pi halves is up here, so this becomes actually minus and then 1, right? 1. But when we take the derivative of a constant, we get 0, so there we are. We're left with cosine x squared 2x. What was our answer up here? Cosine x squared 2x. Of course, I brought the 2 out front. But here's the question. Will you be able to take the integral of this? And chances are, if you're taking a test, they're going to set this up so you can't take the integral of it. So you'll just have to do the substitution and follow the steps. It's pretty easy. And we're going to actually work another problem. We got time. We're going to look at this one down here, which this is another one that we could actually take the integral, take the derivative, and so forth. But we're going to go ahead and do this one here. Alright, so what I'm going to do is I'm going to let u equal the x plus 2, and we're going to also need to solve for x in this problem. U minus 2 is equal to x. But by taking the derivative of this top one up here, we'll write this down here, you get du over dx is equal